So today we'll be talking about AWS machine learning and AI fundamentals, right? Fundamentals, meaning we're trying to introduce AI. We're trying to show you how it is to work with AI inside of AWS, like how easy it is to work with AI and machine learning inside of AWS, right? So as part of the class today, we'll talk about machine learning basics, right? So we'll just introduce it so that you understand like what's machine learning basically. We'll talk about AI services, so pre-trained services that you can use. I don't think we'll get to Lex today. I will not get to Lex, but as part of this series, we're going to cover Lex, Connect, and we'll see a demo, right? We'll see Kendra, Personalize, and then towards the advanced side, we'll talk about the generative AI, Bedrock, which is huge on the AWS side, and then SageMaker if you wanted to more or less like build and deploy your own custom ML models, right? So let's talk about machine learning. Let's introduce machine learning because I think people, it depends on your experience. For me, I have a master's. I did do artificial intelligence as master. So to some extent, I understand because I did, it was part of what I did at my master's level. But machine learning, if you were not techie, right? If you were not techie, it's basically the world today. Everything that you see out there when you hear ML is just the fact that computers are learning from data, right? That's just the thing. That's just machine learning. If you want to look at it in there's more advanced things you can say about machine learning, but if you have to summarize it, it's just basically you're throwing data at a machine, and the machine is learning from that data without you explicitly programming, right? And if you think about how we use it today, even when you think about Gen AI or like your custom machine learning models, they are like that, right? You train them, you train them with data, and over time, even from data that they've not seen, they can basically tell you things, right? So whenever you see yourself talking to ChatGPT, obviously ChatGPT is obviously a very more advanced case of the early days of machine learning, but it's all built on that same foundation, right? So the whole idea is it identifies patterns. So when you throw a lot of data to it, over time it begins to see the patterns in that data, right? And then when you now throw in new data from it, based on what it has seen, it can actually tell you, make prediction, right? So for example, if you train it and say, okay, over the years, I've seen, this is how people have passed or they failed this course, and then you give it data of the people who are passing versus the people who are failing. After you give it enough data and you train an algorithm, after a while, it should be able to tell you, if you give it the same metrics, to tell you if the person is going to pass or is going to fail. That's just basically what machine learning is all about. I know it's more complex than that, but we'll leave that for people who are core into, they want to go into machine learning or you want to go into data science, right? So, and again, the accuracy obviously improves with more data. So when you, not just more data, but more reliable data, right? It's not just throwing data at machine learning. Usually, it's like throwing good data, right? And that's where data scientists are very important to the machine learning to machine learning, right? Because data scientists, their role is basically to clean, get data, clean it, make sure it's usable for your machine learning, right? And which is what's at the end of the day, good data will provide good algorithms, machine learning algorithms, right? So the algorithm there basically will just find the relationships in the data, right? It's not like you're programming that, you is just going to find that relationship, and after a while it can basically tell you that from the relationship I've seen, I can tell you things that you cannot even tell from the data, right? And again, it adapts to new data without your intervention. So because you've thrown a lot of data to it, it is able to adapt as time goes on, right? So that's like machine learning. So it's just the fact that you can learn from data. That's really everything you see there. So even Gen AI, when you see ChatGPT, you are talking to ChatGPT, you go and check it, ChatGPT was trained on internet data. So there's a massive amount of data that has been trained. So everything is talking from experience, it's talking from the things it has seen. And now it's able to help you more or less like, generate conversations around what you give it based on what it has seen, right? So that's basically overview, machine learning overview. So when you think about it, if you look at it, there's like some steps that I did put here just to simplify it, just to make it approachable, right? There is obviously more, but high level, you gather data. If you're interested in doing like you're trying to make inference from data, you have to gather the data that you're interested in, whether it's medical data, whether it's financial data, whether it's academics data, you have to gather that data. And then there's some prep that you need to do to the data. You prepare the data. It may come in some format that is raw, right? You need to do some, some cleaning, some modification to make the data good for your machine learning algorithm, right? And then from that point, you choose models. There are so many models out there, so many models that you can use. You will choose depending on some are suited for the problem you're trying to solve. Some you have to, from trying them out, you see which one performs best for your the problem set that you're trying to do. And then once you pick a model, you train, right? And during the training, there's a lot that also goes in there, right? You train from the data you've gotten. You train the model, and then you evaluate the model, right? Because after training, you have to evaluate if it's doing well. Sometimes if it's not doing well, you optimize, you retrain, you do all that back and forth. You tune, more or less like after the evaluation, you can see if you're doing well or not, and then from that you can do hyperparameter tuning, right? It's just the part where you are tuning the hyperparameters that you're using for the model, um, to more or less like improve the model and come up with a better result. And after that point, your model is ready. You deploy it, and then it can make prediction for you, right? Based on the data you gave it, and based on the kind of predictions you're trying to make, and then you can throw data at it, and it's going to make that prediction. So there's a link in there if you actually wanted to see what that is going to look like, right? Because this is not a machine learning class, we'll just introduce it. You can pretty much read more about it. Um, so that brings us to AWS. And like I've said in all my classes, AWS is not many of the things you see in AWS. Some are native, like AWS build, they've seen so many problems and they come up with their own pattern and they build their own solution. But many times, many of the things we've seen, storage, compute, those things were there before the cloud, right? So what it means is that when you say machine learning on AWS, it's not like you are reinventing machine learning. No, it's just now you're doing machine learning in the cloud, right? So traditionally, you would have your own machine. So all the process that I showed you in the last slide, it means that you would have done it on your traditional machine. You get the data, you prepare the data, you train the data with your model. The only difference there is that you need a lot of compute to do that. Machine learning is no joke. You need a lot. You need powerful machines to do computation, right? To do all that training. But there are people who still do that, who don't need the cloud to do it. They do it. But the cloud gives you many of the flexibility we've seen, many of the benefits that we've seen, that you can innovate quickly, faster, and you can try things out, right? Try, and just keep trying. And so there's a lot you can benefit. Whether you're starting from, if you actually wanted to do um, things that don't even require you to do, you don't even need a lot of machine learning expertise. You can. So you can do. So I put it here as three layers, right? So you can do AI services, which means pre-trained models, no ML expertise needed at all. So Rekognition as one of the services that we're going to see falls in that category, where Rekognition is basically like recognizing things, right? What it means is that you don't need to build your own machine learning algorithm from scratch. You can use something that is already in the cloud. Why reinvent that? If you want to reinvent, you can, but you can find a solution in the cloud that already does that. And then you can also do your own ML service, right? If you actually want to still go back to using the cloud, but building your own ML, custom ML models, you can use something like SageMaker to do that. And then you can even bring in frameworks and infrastructure like do it yourself ML. So if you wanted to do EC2 container and just take like you do use PyTorch and build your own ML, all that is also supported. You have all this, so you can actually get a machine from AWS and do your own custom training. You can also use SageMaker that makes training machine learning models in AWS easy, or you can even go with a pre-trained model like Rekognition and just get your job done, right? So as part of that, you have to think which part. So if you think about how organizations are using AWS today, they will look at these three things to choose their path, right? So if you just want to solve like a vision problem or language or something, you want to do translation, instead of reinventing the wheel, you can use a service like something that AWS already offers to solve that problem. But you can also use SageMaker, like I mentioned, for custom, specific business models. So train your own, more or less like, build a custom model trained on your own data and do your own prediction. All that is there. Or you can even use frameworks and like PyTorch and just have total control if you wanted. All these options are there in the AWS cloud if you wanted. So let's now see our first service in AWS, which is Rekognition. So if you think about it, Rekognition falls amongst one of those services, and you see it very, you see how easy it is to use Rekognition. But the point is that if you actually want to do computer vision for image and video analysis, Rekognition is that service that you can use. What it means is that you don't need to train your own machine learning model, right? So pre-trained models that doesn't need any ML expertise, right? You don't need ML expertise to use Rekognition. So when you think about some of the key features, it can do object and scene detection. So if you give it like a picture, it can actually detect the object in that scene. So, and then you can also do vision analysis, as we'll see. So you can detect faces, emotions, the age. It can tell you if the age bracket the person falls into. Can tell you the gender. All that. You could have apps that depends on that, and Rekognition can do that for you without you crafting your own unique algorithm to do it. Right? You can also do content moderation from if you look at an image, you can basically detect if that image is appropriate or not, and then you can apply moderation on that image. And we'll see it very soon. And you can also do celebrity recognition, so identify famous people. So these are all, some people, they just have this feature. They want to do it, right? So instead of building something from scratch, you can use Rekognition to just do it. So what we'll do is that we'll go to the console, because it's just as easy as I've mentioned it, but we'll go to the console to see what it looks like. But when we come back, we'll now look at a typical use case after we've gone to the console to see exactly how it works. Okay, so I'm going to go to the console. The console is here, and then I'm just going to search for Rekognition. Okay, Rekognition. Okay, cool. So I'll search for Rekognition. So one of the things you see here is that you can do, there are many things you can do, right? So if you let me zoom in a bit, because it has, so you can see, for example, there is an image here. It tells you some things, so here, I talked about some of the features, but if you see on the left, you have label detection, right? So you can basically detect label from an image. You can also go for, like this one, you can see image properties like the brightness, the contrast, the foreground properties, the background properties. You can see all that. You can do image moderation, like I mentioned. So you can do, if you check image moderation, for example, you can see, for example, if a content is, you can actually, let's do this one and see to analyze it. It's going to tell you female, it gives you some properties about that image, and then it can tell you the moderation. It can give you some moderation labels. Non-explicit, this it tells you the percentage if that's something you care about. You can use it in your application to know to moderate pictures, right, or videos if you wanted. You can do facial analysis. In this case, you can see looks like a face, appears to be a female. It gives you an age range of the person. It tells you the person is smiling, appears to be happy, wearing glasses. Remember, these things, it just depends on the kind of application that you are building, right? But the way I'm going to demo, so you can also do celebrity recognition. In this case, it knows it's Jeff Bezos, that is this person. This is the sample request that was sent. So it's more or less like you're sending this, and then in the response, it's telling you celebrity faces, right? Remember that if you're using all the any of the or pre-built services, AI services in AWS, you're going to call them with APIs, and that's exactly what we're going to see in this call. You're just going to be using APIs to interact with them. It's as easy as that. You don't need to do anything special, okay? So I'm going to open CloudShell just to show you a very simple example of using Rekognition. If you had like an app that you wanted to build, you see how easy it is for you to use Rekognition. So CloudShell is opening here, and then I'm just going to open S3 and show you something else. So I'll go to S3. So there's CloudShell here. I'm just going to let it load, and then I'm going to go to S3. Okay, I'm going to go to S3. In S3, I have a bucket here called Brainyl sample bucket, and I'm just going to show you what I have in that bucket. So there are two things that I have. I have friends, right? So think about it. I took an image called Jeff_friend.jpg. I did save the image here. So if I open it here, it's a picture of Jeff Bezos that we just saw, right? So, but I did put it in a folder called my friends, right? In this case, it could be anything. Maybe you have a folder called your employees, and you want to recognize if the person is your employee or not. And what I have also done is I've created a new folder here called test, right? So which is something I want to validate against my friends to see if that person is truly my friend. So in this case, I also have another image, and it's also his image, right? So it's his image. It's the image of Jeff Bezos. But if you see the two images, they are very different, right? So this is my friend. This is what I'm trying to test with to see if both of them match, right? So what I'm going to do is I'm going to go to CloudShell. So the first thing basically, so if you also if I open Rekognition, AWS, let me type CLI so that just so you know, um, how you use them is basically through the CLI. You either you're doing via the CLI or you're using Boto 3. We've seen all that, right? Many of the AWS APIs that you've seen, you can do them via the CLI, or you can even use the Boto 3. But they have a number of APIs that you can use here. So for example, if you are doing Amazon Rekognition image, if you are doing image, or if you are doing custom labels, or if you are doing video stored, like if you're working with video streaming, there are lots that you can do, right? But in this case, we are going to be doing the image one, right? So I'm going to go to CloudShell, and I'm going to use one of the what do you call it? One of the command, which is I'm trying to, first of all, I'm creating a collection, right? So I'm just telling Rekognition I want a collection, and the collection, I'll call it my friends, right? It's a collection where I'm keeping my friends. So I'm just going to do this. Um, and it says, yeah, status code is 200, meaning it has created a collection of my friends, right? So the next thing I'm going to do is I have also another handy command, and I'm just going to copy and then I'll paste it here, and then I'll read through what is there. So I'm saying AWS Rekognition. No, this is not the first command I need to run. I need to first of all, so the first command I ran, I created a collection, right? So now the next command will be um, for me to index a face. So I think the console is a bit broken now. Let me just clear it and paste again. So the first, if you think about the first command I ran, I created a collection, right? And then in the second command, I'm saying I'm trying to index a face, right? And I'm saying you should save the face into my collection, which is my friends, right? And then I'm giving it the image. The image is it basically is parameters, right? So I'm saying it's in this bucket, and the name is friends, Jeff friend. So Jeff friend is exactly this one, right? So once I do that, I'm saying detection attribute all, and then I'll do enter. And it says, it has actually indexed that face, right, into my collection. So one thing you need to know is let's take note of the face ID, right? So it actually saved it, and there is the face ID, unique face ID that is attributed to that face that we just indexed, right? Now we've indexed the face. So think about it. This could be your application. It could just be an application where you're trying to validate your employees, or you're trying to validate your students. You save them, you index them, you create a collection for your students, you index your student, and then the next thing you want to do is you want to recognize a face. So what I'm going to do is I'm just going to do, it did give some properties, and there's an image ID here, but I'm just going to clear. So the next command I'm now going to do is to now recognize a face, right? So search image. I have a collection now. So what it means is that I can actually now do AWS Rekognition, search faces by image, right? So I'm trying to search a face by image now. And I'm giving it my collection. My collection is my friends. And then I'm saying the image that I'm trying to recognize in this case is Brainyl. This is the bucket, and this is test. Remember, this differs. This is test. The first one was friend. And I did give it some variable here, threshold, and then the max. I'm just going to leave the output. Maybe I'll just even use JSON. Okay. So one thing you notice is that it has finished, right? So it can say the confidence. It told me searched face confidence, meaning the confidence from the search that it did, right? But one thing you need to do is that if you see this, the face ID is there, which matches exactly the face that we did save in there. And you can see that the similarity is actually 99% when you see it. And it did give us like the face ID that we had, right? So the thing is that just by indexing the face, we were able to just immediately recognize it, right? Without more or less like creating our own custom algorithm to do that. So what we did is we pushed the face, and then we recognized another face, right? We didn't have to build like a custom algorithm to do that, which is good, right? So what it means is that if you had like a recognition problem, right? Instead of you thinking of building a custom algorithm, you can use Rekognition to basically solve for that, right? So if you go back to this page, let's look at a use case, because one thing, if you want to appreciate ML and AI in AWS, you basically need to expose yourself to a lot of use case, right? And use case can also be you building them if you want to. But one thing you notice is that in this case, for example, the users, this is showing a very use case, and there's a link if you actually wanted to read more. But the whole idea is that the users will authenticate using Cognito, for example. They would upload a picture to S3, just like we've seen it, right? So, and you know that when a picture is uploaded to S3, you can create an event like a Lambda event, right? Like a Lambda trigger that says that an image has been uploaded. What it means is that you can save that image to Rekognition, right? And so what it means is that you can actually run a Lambda that would more or less like even gather metadata information from Rekognition. In our own case, I think we did Rekognition, but you can also go the route of just getting metadata from the image and pushing that to Elasticsearch. What it means is that you can use that at the end of the day to search an image from basically the metadata that that image has. So if you see it here, user upload authenticates through Cognito, just like it is in the image. They upload an image to S3. They will trigger a Lambda function on object creation, and the Lambda will analyze the image. In our own case, we did Rekognition, but the Lambda can also, analyze the image and get attributes from Rekognition, and then to store that in OpenSearch, right, or Elasticsearch, and then you can use that if you wanted to more or less like search. Okay, so if you think about it, that's really Rekognition. It's there, it's a service. It does a lot of the things that we've talked about: object detection, image recognition, and you just interact with it using your the APIs. You don't really need to do much to get it running in your application. Okay. So the next service we'll be looking at is Transcribe, right? Usually, I think when you start doing a lot of the AI, when you find yourself in the AI models, one of the things sometimes is just because you hear so many things, Transcribe, Poly. Sometimes um, I think the only thing people confuse is sometimes you would have heard so many services and you're not a bit confused about which service does what. Okay, and I'll try to explain it so that even if you are not watching the video again, you can remember, right? So how I know Transcribe is transcription, right? So transcription is usually a transcription is like a text. So that's how you will not forget Transcribe, right? So it's like it's a service in AWS that can actually help you convert audio to text. That's basically what it does, and it uses deep learning to do that speech conversion, right? The deep learning algorithm itself it uses is called automatic speech recognition, so ASR, right? So the point is that you can give it an audio and then it can generate text for you, right? So how I always remember this is that transcription is the text. So when you say transcribe, meaning something is trying to transcribe, something is trying to create text. In this case, transcribe will take an audio, it will create a text from it, right? It supports multiple languages. Speaker identification is also something you see. So I think if you also on TikTok here, for example, if you use TikTok Studio, you've seen how you would more or less like create a video, and from the video you can actually maybe more or less like create caption, right? So from a video, for example, you can pretty much generate text, right? And it's the same way you can also do the opposite. I think sometimes you create a text and there is like a place you see in the app, they would say, do you want someone to speak to the text, right? All that is AI in one way or the other, right? Because you can go either way. So you can say that you're generating audio to text or you're going text to audio. But in this case, Transcribe has a specific purpose, which is to convert the audio itself to text, right? You can do something like you can do more or less like custom vocabulary. If you had like some terminologies that you wanted pronounced in a certain way, you can do all that. You can do real time and batch. So what it means is that you can actually do real time transcription, but you can also do it in batch in case you have like the work. It's a lot for you to do. And then you can also do call analytics, more or less like to gauge sentiment from the audio that you were trying to transcribe, right? So let's see what that is going to look like. Many of these services, like I mentioned, is the same way we saw with Rekognition. It's all API based, right? You're basically interacting them with API, so they are already pre-trained models that don't need you to do anything, right? If you wanted to go custom, AWS also has custom tools that you can use, but many of these ones are already pre-built machine learning tools that you can use. So in this case, for example, there's real time, there's transcription jobs, but there's like you can do real time transcription, right? And so what it means is that it requires audio, right? But it needs to generate, it will generate text. You can select like a, you can do like a language that you want. In this case, you can choose, so many languages here that you can choose from. But let's stick with English, right? So I can pretty much just say, this is a class. Okay, let me just say start streaming. So allow this time. I'm just going to start streaming, and I say, I love the class on uh, TikTok. Stop streaming. Transcription out. Let me see. Okay, so let's go again. Start a new transcription. Hello. Um, I feel I'm not sure if my audio is being, I don't know if it's not taking my audio in here, because ideally when I start speaking to see translation, the transcription should have been here, but I don't know if my audio is actually not being, let me see what's happening to the mic. The mic is um, on every visit. Which of the mic is he using? Just to be sure. Yeah, it's using my mic actually. Yeah. Okay, so let me see. Let's go back. So, okay, maybe the setting. I think I'm suspecting that I applied the setting. Hello. Um, hello. Hi. So it looks like somehow my audio is not seeing my audio. My audio is not entering the um, it's actually not entering the, what do you call it? Stop and download full transcript. Let's see. Um, it's here. Let me see Notepad just once. Let me see what it shows me. Because ideally now that I'm talking, it's supposed to, but you can see it's not even giving me any result. So it looks like it's not, my mic is being intercepted. That's what I'm noticing. So it looks like my mic is actually not taking my mic as, um, yeah, I think it's a bit, that's one of the things, because I'm doing this, I'm streaming, and my audio is being used on TikTok. So I'm not sure if that's what's happening at this point. Let me see. Start streaming. Using my microphone now. Set permissions. Hello. Yeah, but it's actually seeing my audio. Okay. Start a new stream. Hello. Start speaking to see transcription. I'm actually speaking, so it's actually recording. I don't know. It's recording, but it's not seeing. To apply updated setting, it said I should upload. Starts hello. Hi. Even if I want to try this in a new browser, it might require me to log in. But the point is that I can basically talk. So I can talk here, and ideally, it's just going to create transcriptions from my audio. That's basically what it's meant to do. It's kind of easy to test, but right now it's actually not doing that. I'm not entirely sure um, if it's not getting my audio, but you guys can hear me, so I'm not entirely sure why it's not doing that. But again, you can saying it said I should leave. I'm leaving the page, stop and download the full transcript, or I can leave. That means it's actually trying to record and generate a transcript, but I'm not seeing it. You can also do, you can filter vocabulary, you can do customize. There's just a lot you can do, but the whole idea is that you can actually take audio. In this case, I'm talking, right? But sometimes it's not. Maybe this is not how you're going to use it, right? Maybe sometimes it's either you're working with an already made audio, or you're also actually streaming someone's audio, or like streaming audio and then using transcription as a service to more or less like create transcription, transcribe as a service, and creating transcription from that from that audio, whether it's real time or something that is already recorded, right? But ideally, it's kind of easy to test. If you go here, you should just be able to do, you should just be able to, you don't really need much to test it out, right? You can actually just start audio, like start streaming, and then you actually see the text here immediately, right? Um, of what you speak into your microphone. So in this case, I think my problem here is my mic. I'm not sure if it's not been, the browser is not, probably because I'm using it here and it's not, I think the app itself has it all. The app is taking everything, but it should be easy. For those of you who have AWS accounts, you can come here and just start streaming, and it's just going to give you what you're looking for. All right. So if you look at what that would look like if you were to look at a real architecture, right, for Transcribe, and there's also a link if you actually wanted to. Some of these things are not things that you can just easily build, but it's good we start exposing ourselves to some of these architectural diagrams because we've seen a lot of them, right? You see how I prioritize architectures when we walk through our problems, right? But in this case, you see that audio recording is sent to S3, so it could be, I think that not too long ago we talked about IoT, right? So in this case, the link that I did paste here, it's about an IoT device that is sending recordings, right, to S3. And once it gets there again, there is like an event trigger when a file gets to S3 that calls a Lambda function. And the Lambda function is just going to convert the audio to text using Transcribe. Remember, all the AWS services around AI, especially the ones that are pre-trained like Transcribe and Rekognition, they are all API based, right? So you can relate with them just like I did with the CLI, or you can use both 3. So the Lambda function is going to take the audio and then send it to Transcribe. Transcribe is going to convert that to text, and then you can send the text to subscriber, right? Maybe using like whoever is subscribed. You've seen we did subscription for IoT. We did both pub and sub for IoT. So think about it that there is a device that is pushing audio, and then there is like something else that is subscribed, and then you can actually send that message to the person once that subscription is done, right? It's all here. So the Lambda function publishes the text message to Amazon SNS, and then we've seen that work, right? SNS can basically notify. You can use that to basically notify the end user. The point is that Transcribe here is basically taking that raw audio and then can help you convert it to text, right? You can read more on this architecture, but the point is that here we're not doing much. Basically, you're just giving it an audio and it's going to convert that to text for you, right? Cool. And there is like a link there if you really wanted to see the architecture in full. But to build this is not going to be hard. It's just that we're still introducing this subject, and it's not going to be easy for you to just build it in one sitting like this. Okay. So let's now think about the reverse of what we've done. Although I wasn't able. I think my mic is being interjected, so my mic is taking TikTok Live is taking my mic. It's not showing, but ideally, just from the browser, we can actually get the transcription from the audio. When you speak to your mic, you're just going to get the text. And so in this case, it's real time. We're doing real time, but you can also take an audio that has already been recorded and basically get transcription from that. So then when you now think about the reverse of it, right? You can take a text now, and then you can convert that to an audio, right? Poly is something that I think sometimes the name doesn't really match. Transcription is easy because you can say transcribe. When you hear transcription, it's like a text, right? So it's easy for you to remember, okay, transcription is really from audio to text. But when you now say text to speech, Poly doesn't really speak it very well. Sometimes that's where the confusion comes. But just know Poly is really from text to speech. So Poly is the inverse of transcribe, right? So it converts text into lifelike speech, right? A human speech. And I think we've seen this also work. So if you see TikTok, I think I mentioned if you've done video editing on TikTok, you notice that at some point you have a text and it can tell you, generate speech from this text, and it will even give you option to choose different voices. It's exactly how Poly works, right? So neutral voices, meaning naturally sounding human-like speech, you can get that from text. Multiple languages and variants, we've seen that also with Transcribe. You can do transcriptions in different languages. You can obviously do customization, meaning you can control the pronunciation, the speech rate, the pitch, all that. You can do some customization in terms of how you want the audio to sound, right? You can try different style, like I mentioned. It's also there when you do your TikTok videos. You see that you can try some, different types of style depending on how you want the audio to sound. Okay. So let's see what Poly is going to look like. Remember, I think let's go back to, we did Rekognition. I think we saw Rekognition as an API, but if I do transcribe, transcribe here, for example, is the same, right? So, I just changed the URL. The point is that many of these things you are just going to create, you're going to be relating with them with API. In this case, this is CLI, but all these calls will also be in Boto 3. The point is that you can do things like um, something like, let me see one that is, so you can do like get call an analytics job. You can create a transcription job, right? So a transcription job is basically a job that will do a transcription, right? So it means that instead of how we're testing it in the UI, you can actually call an API, pass a job to it, and then pass whatever audio you have, and then that is going to do the job for you, right? Cool. So the point is that all these services that we're talking about are services that you don't need to deploy them. You basically just need to call an API and it's going to do the job for you, right? So if you go to Poly, so let's go to Poly. So we type Poly. As simple as this service sounds, you can build a lot of great applications with them, right? It just depends on. So here you're going to try Poly. So here I'm saying I'm root. I can read any text for you, test it out. In this case, it's generative. I basically will say listing.
Hi, I'm Ruth. I can read any text for you.
So
Test it
that's,
out.
yeah. So I don't know. Can you guys hear anything from the did you guys hear anything? Did you hear anything? I'm not sure now, but I heard something. Can someone put in the chat if you heard something? Okay, you did. Okay, so basically in this case, you are giving it a text. Yes, you're giving it a text and you're basically generating audio. And the whole idea is that you can go neutral. For example, this is generative. It produces, so all these things are tweaks that you can have. But here you can also try
Hi,
this one. So
my
it's
name is
neutral.
Ruth.
I think this
I will read any text you type here.
I think we use many of these things in applications. It's just that here we're trying to be builders in this case, right? But some of these things are things you already use, right? So you can do standard, for example, you can change the voice. And in this case, this is a female. Maybe we want to use a male. You can listen.
Hi, my name is Matthew.
Yeah,
I will read any text you type here.
yeah. So the whole idea is that we give it. I love teaching AWS on TikTok, right? So let's just try this one and see. Let's try female, in this case Ivy. Let's make it neutral and then let's listen.
I
right?
love teaching AWS on TikTok.
Okay, cool. So yeah, basically you give it a text, it gives you an audio. I mean, you may have your own use case. There are many places you want to use that, and I'm going to show you like an architectural diagram that is also trying to do something with that, right? So you can download, right? When you create audio from a text, you can download it, you can save to S3, you can do all that. But remember, this is us testing from the UI. This is, you pretty much do this at testing phase, but in the real implementation, you'll be calling an API. So for example, if I go up here also and I go to Transcribe, which is like the home page, and I just switch this URL and I type Poly, for example, you see, it also comes. So it comes here like, you can have its own synthesized speech. So you have a number of actions that you can basically do, right? Cool. They are all things that you just relate with via APIs. Okay, so let's see like a sample, more or less like a sample architecture for Poly. So if you think about it, there's like a browser. There is a browser here. There's also a link if you're interested. And I've said it on this call. If you've been following me for a while, you need to, number one, know how to draw your diagrams. That's number one. But number two, you need to also be able to look at diagrams and understand them. Right? I think that's just the level I am right now, where I see a diagram. You don't need to tell me anything. Just looking at the diagram, I can tell what the architecture is trying to do. So in this case, there's basically more or less like, first of all, there's the website that is hosted using CloudFront. We've seen CloudFront here on this call. We've built something around CloudFront, right? So, so there is like a CloudFront hosting a website, and then there is a user who is calling API gateway, and that API gateway is going to call Lambda. We've seen API gateway calling SNS, right? But you know that we can also see API gateway can have direct integration to Lambda, right? So in the case of calling Lambda, it can actually convert, create speech, audio, and speech mark files. So the point is that just like we've seen, that Poly will take a text and create audio from it. So you can actually, in this, what was shown here is that you can type a text in the UI in the front end application, and then an audio is created from you, and then that audio is saved in an S3 file, and then that you can actually listen to the audio even in that same UI. You can read more about it, but the point is that people usually have their different use cases, right? But the most important thing, the role Poly is playing here is that it's taking a text from the UI and is transforming that to an audio, saved back to S3, sent back to the user to play, right? So yeah, it's those are standard stuff, right? You can basically send an audio to a UI, and then you can have like even an HTML5 element that can play the audio out, right? So those are standard stuff. But the point is that many of the things here we know. Most of the people that I'm talking to on this call, they know this part, right? The only thing that is new is just the fact that Poly is here, and is somebody's a user is calling API gateway with a text, and that text is being sent to Poly. Poly is generating an audio, and that audio is being saved to S3. So it's standard stuff. I think it's standard. The only thing we're introducing is Poly, right? But this architecture, you can also read on it. It basically speaks more about what has been achieved, right? So we've talked about recognition. All these are all API-based services, already made services that you can use. Recognition. We've talked about Transcribe. We've talked about Poly, which is like the opposite of Transcribe. What about Textract? Textract is basically document processing service, intelligent document processing service. So the whole idea, you have a document, and then you can extract text from the document, right? There are many ways you want to see it. Sometimes, I know in the old way, you usually would scan. Just think about it. You have like a legacy process, and someone has so many documents that they've saved over years, and they want to transfer all those documents. They want to maybe like digitize it or something, and you are introducing a process into it, right? So Textract would help you in that kind of case, because now you can actually take that document, extract text from it, maybe forms, maybe tables from that document, and then use it to either do more things, whether train a machine learning model or save it into a database or archive, whatever was stored physically before. There are many ways you want to do it, but the point is that it's really a document processing service. So it will take a document and it will extract meaningful information from it, and we're going to see. So it actually goes beyond OCR, because it can actually understand your document structure. It can do really, really more things, right? So when you think about the capabilities, it can do text extraction, printed and handwritten text. So just give it a text, give it a document. It's going to extract meaningful information for you to use. You can also see form data, so key value pairs from a form. And then you can do table extraction. So if it has like a table structure, Textract can do a very good job at preserving that. Identity document is something you would see. I'll show you what that one looks like, because you may have an application. All these things also begins to open your mind. It begins to open your mind to many of the possibilities and some of the solutions that you can build, right? So if you have an application, for example, that needs to, somebody is giving his identity, more or less like his identity document, and then you can basically use something like Textract to extract that, the key information from that person. That's the example we're going to see, right? Also for invoice and receipt, if you have like physical invoice and receipt that usually generate, you can basically, generate structured data. You can do structured data extraction from that kind of invoice and receipt, right? All in the bid to either put it in a database, store it keep it in the storage, or use it for maybe even a machine learning engineering stuff, right? So let's see Textract. I love this one. So we're going to see Textract, okay? So we're going to see what that looks like. It will have its own example, but I'm going to show you an example that I really want to show. And the whole idea is that these things begin to open your mind to the kind of solutions you can build just using the power of the cloud, right? And you can see automatically extract handwritten text or data from any document using machine learning. That's the selling point. And there are many ways there are many places you want to use this, right? So you can analyze the document. In this case, there is a document on the left. This is a normal document. So if you think about somebody who has not been in the cloud and they're trying to move to the cloud, maybe they had all these, they've been collecting it manually, and then you wanted to build a process around it. You can see it gives us the raw text on the left. You can do the layout. It tells you more or less like the layout, how it is laid out. You can see the forms in the, you can see if there are any forms. You can see CO, ABC, file, tables. It breaks it into tables if there is anything. You can do analyze expense, right? So this is an expense. You can do analysis of that. But I really want to analyze ID. I think they did have an example they're working with here, but you can see if you choose, it breaks it down. So if you have like somebody, if you have an application that usually needs to take like an identification. You can use Textract to basically, instead of you telling them to even manually fill their names, you can get it from the identity card, get their age or, many of those information that you need. So let's actually try one. So let me see if I still have that document. If I'll choose document here, let me do downloads. I think I did put, yeah, PR card. So what I did was I just went online and I just picked, obviously this is not the real PR card, but this is how Canadian PR card would look like, right? So what I did was to choose this document. I think it has even done its thing. um, yeah, immediately I chose the document. You already saw it's a PR card. You can see it already gave me the first name. The last name is Specimen. The middle name is Yasmin. Document ID, it knows from seeing the ID of the document. It sees the date of birth already, expiration date, the driver, the ID type. It did say driver's license front. So I'm not sure how it got driver's license front. But the only point is that, yeah, you could have something that you have user upload their ID, and from there you can match their information, verify their name to see if their name matches what is on their ID. So whenever you see all these apps online, you're beginning to get to that point where you now know exactly how it's done. It's not magic. These are the things, right? You can use something like Textract to basically take like an ID and just do extract text from it, right? So what it means is that if you have an application or you're ever thinking of building something that can do that, why reinvent the wheel? You can basically use Textract to do that, right? So this is one very good example of just taking an identity card and just getting the information that you're looking for. Cool. So we're also going to look at this a sample architecture. Trust me, these architectures that I'm pointing out to you, they are not hard. Okay, they're not hard. If you think about them, many of the services that I did mention in this architecture, many of them are things we have already covered. The only things I'm introducing are the new services that I'm actually talking about. Okay. So like in this case, for example, a user would upload S3. You see how powerful S3 is? Especially if you're dealing with machine learning, data science, or when you now start to do with machine learning, obviously AI, right? S3 becomes very important, right? That's like the go-to storage for many of the things you'll be working with, right? So in this case, the user uploads image for analysis into S3. S3 again, there's always this S3 Lambda integration where there's an event when something is pushed to S3, Lambda can take that. And in this case, what is really happening is that comprehend is something I'm going to show afterwards, but Textract here is just basically extracting text from the image, right? And that image can be pushed into Elasticsearch or OpenSearch, right? We know Elasticsearch, OpenSearch, they're all indexing and where you can index and you can search easily, right? So it means that if someone has an image, you can basically index the text from the image such that you can now search those texts. Instead of searching with image, you search based on the text. But how will you convert the image on the text to the text on the image to text that you can search on? And this is just a simple solution to do that. So one example is that if you have like an application where users upload images, right? And you want to give them the capability to be able to search their images with the text. Textract will do that perfectly, wonderfully well for you because you can collect the user's image. You can use Textract to extract text from those images. You can index that to a search service like OpenSearch, and then the user can query those. It's like you can find even their images using text, right? Because if you just dump the image, there's no way. How do you want to? It's going to be hard. It's going to be more hard for you to just go and be searching image based on the text that is on the image, right? But if you use something like Textract, and you can actually, we'll see comprehend what comprehend does later. But comprehend is also like, more or less like another service tool that you can use. But in this case, I'm just saying the role Textract is actually playing. Okay, so you're extracting the text from the images, and then you're putting that in OpenSearch or Elasticsearch, and then the user has a very fancy, like there's a UI that you can search. But now you're not searching based on your image again. Rather, you're searching based on the text that was in the image, right? So also everything that's here, I don't know, it's not too complicated because your Lambda would, like I said, a Lambda would always reach Textract using the APIs. So it's not, you don't really need one machine learning model to be running somewhere for you to do all the things we're saying. It's just the same way you call easy to start or terminate, and all that. Cool. That brings us to one of the favorite ones. I mean, translate is obviously easy. That's like very, very easy. So we've seen Rekognition, we've seen Transcribe, we've seen Poly, and then we've seen, we just talked about, let me just go back to the Textract, right? So translate is translate, basically. People do have, so also, translate is not new to AWS. Like it's not new to AWS. People already have a way they translate their if they have like something they're working on, right? So they can obviously use Translate to do whatever they're doing. But you can also use the Translate service in AWS to do neural machine translation. So it's like a neural machine learning machine translation service. The whole idea is that translate text to text, but text in one language to another language. You should know that that's like a machine learning problem, right? That's translation itself is like a sequence to sequence problem. So, but the whole idea is that you can translate text from one language to another language, and Translate does it well. So you don't need to reinvent the wheel. So if you have any part of your application that you want text represented in a different kind of language, why should you have to stress? You can use Translate to do that. Supports a lot of languages, real time and batch. You know, the whole idea is if it's a small job, do it real time. But if it's something that will take time, maybe you want to do it batch. You know, and then you can also do custom if you wanted to do like branding, custom terminology to do like if you had like brand names or domain specific terms that you wanted to inject, you can have all that. And then you can even do automatic language detection, right? So we'll see what that looks like. It's also not many of these services are not hard. We're just looking at them. I think many of them you begin to see the value once you start building something from it. But you should know that at the end of the day, sometimes it's either they're opening your eyes to the kind of solutions you can build, or when you see a solution that is out there, you have an idea. Okay, I think I understand the technology that's powering this thing, right? So here in this case, auto meaning select language auto. Where do we want it to go? English or whatever. In this case, it's English, right? Hello world. Let's see what is going. So translated text is hello world, obviously. But let's see if it's in French. What would that be? So French, Canadian French, just the normal French. It's gonna be this, right? So we see what it is. But you can also put the exact language you're trying to transfer from and the target language, right? But again, if we go back to our APIs and we do translate, I hope there is something like that. So let me do translate. There is also an API, right? So it means that everything you're doing in the UI, if you're actually going to use it in the real world, you're going to call an API like translate text, right? So you translate the text, you give it the text, you give it the source language, you give it the target language, and that's it. Basically, that alone is going to translate the text for you, right? This is doing it via the CLI. What we're doing just now is doing it via the console. Like with all the services in AWS that we've seen, you can do it in the console, you can do it in the CLI, you can use both 3. So in this case, if you wanted to do it in CLI, it's going to be this. And if I go and check Boto 3, there's obviously going to be Boto 3 translate as a service, and then you just call the translate text API, give it a text, source language to target language, right? Cool. You can basically do all that real time. You can also just upload the document, right, and choose where you want and the target language, and it's going to translate that entire document, right, for you. So the point is that you can do real-time translation, batch translation. It's a service. It's a service. Many of them, people don't really, some people just be like, oh, it's straightforward. It is straightforward. It's meant to be straightforward. It's not meant to be hard, right? Because you don't really need to reinvent the wheel. If you have a problem that you need to solve, I think from what I've seen, people don't really know the problem they're trying to solve, right? But when you see the problem you're trying to solve and you see, oh, Translate already does it for me, why not? You can just basically use it. So let's also see another architecture that would use Translate, right? All this architecture, they're all from the AWS blog, right? I mostly use the AWS blog for many of the information that I share here, right? So in this case, we've seen in the UI that you can upload a document. You can also just type text. So in this case, user, maybe it's like an offline, more or less like a user, like you have a website that displays different language version of the website, right? So in this case, maybe they upload documents to S3. Again, S3 will trigger a Lambda function. The Lambda function is going to probably here, there's like a step function. That's how it was explained in the document. What we've seen what step function is, it's just an orchestration, right? But the inside of it, all that is happening is that Lambda is calling translate to try to translate the documents. And it's also there trying to see the status of it to make sure that, okay, I'm waiting to make sure that, you can do real time, you can also do batch. So in this case, it is translating it in the background, and once it's done, it sends it to an intermediate bucket, right? And then at the end of the day, when everything is done completely, there is like an output in S3 that shows that the translation is done. Maybe that's what you want to render in the UI. Maybe in a particular page, you want the user to be able to switch depending on the language to see a language version of that document, right? There are many places. I mean, some people don't really build apps. I don't know. I mean, some people don't really need. Some people don't really. People like it just depends on the use case you're trying to achieve, right? But if you go to many, localization is a big deal. Like localization itself is very huge in terms of like different projects and how you can pretty much localize your content, localize your website. Because you also want to be sure that the people who are coming to your website, even if they don't speak English, they still can relate with your content and and all that. So the link is there if you want to follow to see more or less like what that is going to take us to. So that brings us to I'm not sure if that is the I think there is, yeah. Okay, so two more services to go. So we're going to be talking about Personalize now. Personalize is also, yeah, one of those services that in AWS you just is also it's there. It's already made, right? So if you think about TikTok, TikTok is obviously like has one of the best algorithms there, right, out there. When you think about your For You page, how things are being recommended to you, how you can just go into your For You and you're already being recommended to, right? But if you think about it, it's not just recommending. It's basically looking at your behavior. It's looking at how you're using the app, the things you're liking, the videos you're watching longer, the live streams you are joining. All that. It is learning. It is more or less like it's trying to understand you. It's more or less like painting a story. And then once it knows you, it begins to recommend content for you, right? So the thing is that Personalize is a recommendation solution AWS has, and it is exactly what powers Amazon.com. So if you were doing anything on Amazon.com, for example, you see that if you buy something, they will recommend something else for you. After a while, if you've used the site, you will see recommendations popping up here and there, right? Because it's seeing you, it's seeing the things you're clicking, the things you're adding to your cart. It's beginning to understand those things to see the things you like and the things so it's a fully managed recommendation engine service. It's exactly the same technology that powers Amazon.com. Remember, Amazon.com is different from Amazon Web Service. Amazon.com is a huge, we know what Amazon.com does. But as part of it, recommendation is a thing. So you can do real-time recommendation, product content, search results. It's recommendation itself is exactly how it is, but you can tune it to your need and you see what that will look like, right? User segmentation, you can group users with similar behaviors. That's the whole idea, right? Because the thing is that recommendation is basically recommending, but you can also, in the process of recommending, you can begin to see people who are similar, who likes certain things versus the people who like other things, right? So you can also do customizable, train on your data for specific use case. So Personalize is one of those services that you can also train your own data, more or less like your data for a specific use case that you want to capture, right? But again, all of them don't require like strong ML expertise. So all the services that we've seen, they're doing the ML related stuff because translation is an ML problem. All the things we've seen is using machine learning, but we don't need the expertise to use those services, right? So let's go and see what Personalize looks like. So we'll see Personalize. We'll see what Personalize looks like. There is like a sample here that you can play with. So if you go, I think this is me who created my data at some point. But what one thing you need to know about Personalize is very easy to use because at the end of the day, let me go to my data set that I've created. So I already created, where was I just now? Manage data set groups. I already have a data group. All right. So the most important thing when you're creating Personalize, when you're working with Personalize, is that this is, you can see this is optional, run data analysis, but one of the most important things is your data set. So I'm going to go to data set. So data, we'll go to data set, and you can see here, if I say create data set, for example, or let me do this one and say create data set, right? So the most important thing Personalize needs from you is to say item user ID versus item ID. That's it. So if you can give Personalize a relationship where you have a user ID and the item they got, then it can recommend for it. It can basically come up with a recommendation to tell you. And there's like a sample here. So if you do, for example, get started. Let me see. I think there is one here where you can do experience the magic. You can just click on it. You can accept. Obviously, I'm just doing start. You can do continue. It's like a small challenge. Become a user. I'll call myself my name. So I'm Brainyl. and I'll just choose, I'll save and continue. I can show popular movies, and basically I can, select the movies that I like, select one more, and then I'll see recommendation basically. So you can also mimic something like this. You can have a user and the items they love, and then you have personalize, give you recommendations based on what the person will like, right? So it's done. So it's now recommending from me, right, based on the thing that I picked. Maybe I like these videos, maybe I like this, I don't know, but I mean, it's from usage. You have to use, you have to see if it's working exactly how you want it. But the data set is really the key part of it, because in the data set, you would have to actually see, you can do user interactions, meaning user items interaction, right? So there's a users list, there's an items list, and there's a user interaction. But there is also the new ones called, like, you can create action, and then you can do user action interaction. Maybe in your application, you want to track users, what the things that users are doing, the places they are clicking. You can keep all that. So you can go here, first of all, create the set of actions, right? So action ID, given an action. And then you can also go back and then create in the data set, you can also go and create user action interaction. So what the whole idea is that a user, this will now have action, the user, what kind of event were they doing? And then Personalize can actually, generate recommendations based on seeing that event. You don't need to do anything. Just throw your data in there and then experience the magic like we saw in here, right? So that's basically what Personalize is all about. Some applications need like recommendation, personalization. Maybe some application doesn't need it. But again, if you have that kind of problem that you want to solve, there is a tool out there that can do it for you. Not a tool in AWS that can do it for you. So let's see a sample architecture, what that would look like. So here, um, like I said, the data set is the most important, right? You have to create items, interactions, and the users, right? So the users, the items, and the interaction. We just saw it. It's very simple, like user ID, item ID, and then user likes this ID, user, interacted with this item, and then upload that to. So here in this case, there's like two ways. There's like where the ingestion is happening at the top, and then at the bottom, we are basically getting recommendation. And then at this point is when we are calling Personalize to basically get recommendation, right? But at the top is where we are pushing in the event. So we're pushing in the event to more or less like push it to Personalize to create that data set, right? To we saw a set of data set just now, right? So usually there will be like a set, something in your application that is gathering that data, user interaction, the actions as they're taking it. Maybe it's a ClickUp event. You're pushing all that. In this case, they're using Kinesis data stream. Maybe you could use something else. But the point is that it's like a click stream event. It's going through API gateway, through Kinesis data stream, through Firehose, and they're pushing it to a Lambda function that is writing that event through to Personalize, right? To create that personalization that you need. And then you can also go through a Lambda, for example, through API gateway to get the recommendation that you're looking for, right? The link is also there if you want to read more. Remember, we're still just familiarizing ourselves with many of these tools and seeing the technology and how you can actually use it today. Okay. Yeah, that's basically it about Personalize. The last service I'll be talking about today is going to be Comprehend. And comprehend is really comprehension, right? To comprehend something. It's a natural language processing service. The idea there is that it can actually extract insights and relationship from your text. We've seen how Transcribe, we've seen how Textract can actually extract text, right? So that's just its job, to extract text, but it doesn't do more. It doesn't really need to. It doesn't do things like finding insights, finding relationship in the text, understanding, entities. It doesn't do all that. It just extract text for you. So there are places where maybe you just need extraction of text, but also sometimes you want some comprehension with the text you are working with. That's where comprehend comes in. So you can do many things like sentiment analysis. So you want to know if you give comprehend a text, for example, you want to see, are there people involved? Are there places involved? Dates? Are there organization? Sentiment, sorry, is what I wanted to talk about. So sentiment analysis in terms of like, is it a positive experience, negative experience? There are places where it matters. Or is it a neutral experience or a mixed experience, right? But you can also do entity recognition, people, places, dates, organizations. You can gather all those things using comprehend, right? You can do key phrases. You can do language detection to see what the text, what the language was about, or which language was the text. And then you can do topic modeling, right? So you can discover topics from a text. And then you can also do PII. You can do detection, so more or less like identify when someone's name is actually in a particular text. Okay, so this one is nice. I think it's worth seeing. It's actually worth seeing. So we're going to go to comprehend. The names are good. I mean, if you think about the names, I think only Poly sometimes throws me off. Like I'm like Poly, like, but the other ones are kind of easy to relate with. So I don't think anyone to. I don't think you would struggle if you're working with any of them. But launch Amazon comprehend. Let me just see. In this case, it says built-in. Let's just see what they have here. So this is text. Like in this case, it's just a text. You've seen how Textract can actually extract text from image. But in this case, you actually you're giving like a text to it, and then you're analyzing it, right? So here it's going to give you things like, so let's look at the sentiment. You can see, for example, key phrases there, but language, it detected English. It gave you the more or less like the confidence. The confidence here, it knows 99% English. Sentiment is what I talked about, neutral. So 62, positive, 62% positive, 23 neutral, mixed and all that. But we're going to play around that now. So you can also do targeted sentiment. There are many things you can do, right? You can also entities. So you can actually see there's a person in the text that was generated. There's John, who is also a person. There's an organization. And there are times where these things matter. You're trying to, look at the text, fetch all the entities. It depends on what you're doing. But let's look at a very typical example. So here I'm just going to say, hi, my name is Brainyl. I spoke with one of your agents today, and I was dissatisfied with the response. Please, I'll love to speak with the manager. So let's analyze this one, right? So let's see what it's going to do. So let's analyze it. I'm really curious about it. So he sees Brainyl is an entity because I said I introduced myself, right? I said my name, so he knows my name is Brainyl, right? I mean, he was able to say that's the person. The confidence is 99, like he knows. Quantity 1. Not sure where did he even see the 1. Yes, spoke to one of your agents. So 1. Date today. Okay. Did I say? Yeah, I think I did say today, right? So it knows. It actually knows that today is there. And I mean, there are places you can use all this, right? But what's the language? I obviously spoke it in English. PII, it did recognize Brainyl, right, as PII because that's my name. Sometimes you want to abstract, you want to hide those things, right? You don't want to show them. You don't want people's personal information to be displayed. But the sentiment is really what I wanted to see. You can see. It says negative, maybe 46. Maybe I was dissatisfied. Maybe I was not happy with the response. I actually want to see something that is like a bad sent. Yeah, you can see the negative. It did change, right? So you can think about it. If you have like a call center where people are calling in, they call in through their voice. From that voice, it's becoming text. From text, you can actually throw that text to comprehend, and comprehend can actually tell if you can see it. That's how you know from like a call. How do you think when you call an agent, for example, and they can know when you're happy or not? So somebody who is like the lead, maybe team lead, is going back to look at all those calls, seeing the ones that were like positive experience, or it was like a negative experience where the person that called wasn't happy because of how maybe the product treated them or something like. So you can go back to these things to see all that, right? But all that is possible. You first take maybe the audio, you convert that to text, and then from that text you can pretty much generate things like this, right? So it just depends on the kind of application you're building. Many of these things you can get those sentiments and use them in your application, or use them also to more or less like, some of these things can actually become input to another machine learning process. Just so you know, it's not about, you're not most times it's not like you're using, sometimes you're not using them directly. Sometimes you're also using them as an input to another process, right? So that's, you need to open your mind up to that point to see that sometimes it's not just direct that the application is using. Sometimes people use one process to provide data for another process in the machine learning pipeline. Okay, so this is one of it. So let's go to what the a sample architecture is going to look like. So in this case, let me try to look at what we're trying to do here. So if you think about it, um, there is like file, you upload a file to S3, that is obviously going to launch a Lambda. We've seen that over and over again. Textract is going to take all that and then send a message to SNS. But one thing you need to see here is that apart from Textract, right? So Textract is sending message, but the Lambda itself is what is checking Textract to see if the text has been extracted. But comprehend can also now do more, right? Remember that Textract will just extract text, but comprehend can do sentiment. It can do sentiment analysis. It can do many more things. So you can use that. Maybe you can store that information to DynamoDB, or maybe your whatever search, whatever data store that you want to put it. And with that, you can basically go back to do analysis to see who was happy, who was not from the call and all that. So there are many things you can do. In this case, it's like an image, and from that, a text was generated. And then from the text, you're actually now passing that text through comprehend, right? Remember, Textract can take an image, generate text, and you can take that same text, pass it through comprehend to now do more things, do sentiment analysis, and then depending on what you find from that text, you can save it into a store or do something with it, right? Cool. There is also a link. Some of these things are not. They are all architectures that we can look at if you're interested. Just be in love with looking at architecture. Sometimes even if you're not building it, just look at the architecture. Just understand what are they trying to build. It's not a must that you're building it. All right. Sometimes you can just read it for learning sake, also just to open your mind. Not every architecture that you see out there that you just see and build. Some is just opening your mind to see, oh, this is possible. Oh, I can go with this. I can use this pattern. Because the more architectures you see, the more it's opening your mind to the kind of solutions that you can also build in the cloud, right? Cool. So I'm going to stop. I'm going to stop here. I'm going to stop in comprehend. For Lex, obviously, when we start talking about Lex, there's some things we're going to build. But here I'm going to stop here because if you look at all the services that we've seen, they're all API based. We didn't really, we were dealing with them in the console, but if you actually want to deal with them using the CLI or the Boto 3, they're just going to be API calls because these are already made algorithms that you can use. You're not reinventing the wheel. Okay. So I'm going to stop it here because the recording is already becoming very, very long. Cool. So I'm going to pause the recording